Today we're talking about exponential functions, which is section 7. An exponential function is a graph, and it also uses the same idea of a geometric sequence as we talked about in the previous section. Just a reminder, the formula for a geometric sequence as review was a to the n times a times r to the n minus 1. Now, in this case, an exponential function is very similar to this formula. An exponential function is going to be a function in the form f of x equals a times r raised to the x. The only real difference is instead of n minus 1, we're going to have an x. We still have function notation f of x. And instead of putting in for n, we're going to put in for x. So our first question says, evaluate for the numbers 4, 5, and 6. So, by now you hopefully have remembered that 1.5 is our first number, and 2 is our common multiplier. Well, to find the value of 4, we're going to plug in the value of 4 for our exponent. Well, that's pretty simple. 2 to the 4th is 16. So 1.5 times 16. You might want to use your calculator if you needed to. If you didn't have your calculator, you could work it out by hand. But the answer is 24. Now I'm going to show you the formulaic way to do this, and then I'm going to show you a shortcut at the end. If you think you know the shortcut, maybe you can write it below as we work through them. Our next one, we're going to find the value for the function evaluated at 5. So that's 1.4 times 2 to the 5th. That's 1.5 times 32. Well, 1.5 times 32, that's 48. So the 5th term for this problem is 48. Our last and final problem is for f of 6. So now we're going to plug in the number 6 for the value of x. Well, 2 to the 6th is 64. 1.5 times 64, that's 96. So our 6th term is 96. Now, let's compare our three numbers. Do you see that our three numbers, 24, 48, and 96, are all multiples of 2 apart? Well, you might have picked that up by the geometric multiplier, called the ratio, being 2. If you knew the number 4 and you know the multiplier is 2, you could just multiply by 2 to get the next one, and by 2 to get the next one, and so on and so forth, so long as the numbers they're asking you to find are in order as shown. Example 2, as we look at the bottom, deals with an investment concept. If you are investing money and it's doubling in value, that's actually a geometric sequence or an exponential function. Here, let's look at what we have in comparison to our general formula. F of x equals a times r to the x. Do you remember that a is the initial number and r is the multiplier? Well, here our initial number is 600. It's doubling. That means our multiplier or our ratio is 2. How often is it doubling? Well, it's doubling every 15 years. So our time is every 15 years. Well, let's take a look at what this is. As we're thinking about it, after 30 years, we could think through this. Well, how many times is that doubled? In other words, x represents the number of times it doubles. After 30 years, it's doubled twice, once at 15 years and once at 30 years. So, f of 2 equals 600 times our multiplier raised to the second doubler. Wow. After 30 years, we have 600 times 4, or $2,400. What about after 45 years? Well, after 45 years, that's 3 doubling units. So that's 600 times 2 to the 3rd. What is that? Well, that's $4,800. So, after 3 doubling cycles, 3 cycles of 15 years, it's 4,800. Now, do you have to use a formulaic approach to solve this? No, you could just use common sense. You start with 600. After 15 years it doubles. Now you have 1,200. After 15 more years, you're at 30 years and it doubles again at 2,400. And after your final doubler, 15 more years at 45, it doubles again to be 4,800. So in many of these cases, common sense could win the day for simple problems. But this formula takes a great deal of effect when you don't have nice, neat, even numbers. What if it was 30 years, 35 years, 40 years, and in which case you could take this as a decimal, 2.3, 2.4, etc., in terms of dividing by 15 to get the number of times it might be doubling.